Hi, this session is presented by the Kubernetes VMware User Group. This is about running all forms of Kubernetes on the VMware infrastructure platform. I'm Steve Wong, co-chair of the VMware User Group. I work on Kubernetes and a few other open source projects as an employee of VMware. Today I'm joined by Myles Gray, the other co-chair. Myles is a senior technical marketing architect in the storage and availability business unit at VMware. We'll give contact information and a link to the deck at the end, but here's the agenda. I'm going to start with a really quick summary of what moving out of tree means and why it's happening. Two components are moving out of tree, the cloud provider adapter and the storage adapter, and we'll cover each of these. We'll move on to best practices for configuration and wrap up with some links to resources. Hopefully you'll like this talk, and at the end, I'm going to provide details on how you can become a member of the Kubernetes VMware User Group, where we host ongoing discussions on topics like the material in this talk. So here's the origin story. Many years ago when Kubernetes was young, actually that was only about 5 years ago, Kubernetes was being built for what was a small set of popular hosting and storage platforms. The code to support these platforms was built right into Kubernetes, all packaged into each release with code to support things you needed, unfortunately along with some things you probably didn't need. Yes, Kubernetes was like one of those monolith things that your mother told you to avoid. As Kubernetes gained popularity, more and more cloud providers and storage plugins crowded into the train. It became obvious that this was unsustainable. It's kind of a bad thing to have each release get monster sized. It slows down releases and patches, and it increases the security threat model. Over 2 years ago, this flaw was recognized and work began to move cloud providers and storage plugins out of the Kubernetes code base, enabling these plugins to be developed and released independently of the Kubernetes release cycle. It was recognized that this was a large undertaking and would take several years. Well, now that work's finished, and for the most part, for most users, it's time to move on. So the cloud provider is the abstraction layer that hides the underlying variations between one platform and another. Storage, networking, and potentially a few other things use different technology on different clouds. And the cloud provider abstraction is what enables Kubernetes to host apps that don't care and to a large extent can't even tell where they're running. The cloud provider enables the portability in Kubernetes. Now, some of these abstractions handled by the cloud provider are optional. For example, public clouds usually have a single choice of a built-in load balancer service, so they build in a load balancer abstraction. With vSphere and other on-premises solutions in general, users don't have a single standard implementation of load balancers, network routing, etc. So in the interest of maximum choice, the vSphere cloud provider leaves this up to the Kubernetes user. A few things I want to point out. The legacy in-tree cloud provider is linked and used with the in-tree storage plugin. So these are tied together, and my colleague Myles will talk more about storage in a moment. Also, even though I just said that the vSphere cloud provider doesn't have the load balancer abstraction, the code technically does have a disabled by default alpha feature gated facade for an NSXT load balancer. At this point in time, this is a recommended for general use, and alpha features are subject to change and even future removal. But I just want to point this out for the sake of being 100% accurate. So here's a logic flow that gives you an in-tree versus out-of-tree recommendation. My summary, for most users, you should be on the out-of-tree right now. And eventually, you're going to be forced to go there because the in-tree version will go away. Exceptions, if you use a Kubernetes distribution, do whatever your vendor recommends and let your vendor manage the work of migration for you. The other exception is if you are running a really old Kubernetes or an older vSphere version, you might be stuck on entry. Kubernetes 1.13 dates back to December of 2018. So in my opinion, you shouldn't be there anyway because it's no longer getting security patches or bug fixes, but I recognize that some people might be on this. vSphere 6.7 U3 isn't that old. It dates back to August of 2019. But some people face impediments to a vSphere upgrade. Maybe it's a license issue, or it could be a legacy hardware issue that is where you've got old enough servers that they can't be used to install a newer version. So for now, you can stay on entry if you really want to. It hasn't gone away yet. But if you're on entry, you're missing out on new features, and community-based support is always better when you're doing with whatever most other users are doing. I also want to point out that the vSphere 6.7 U3 requirement for Outoftree refers to the vSphere vCenter server. If you keep a handful of old legacy ESXi hypervisor hosts around, as long as you have also have some new ones and your vCenter is the newer version, this is okay, as long as your Kubernetes nodes run only on the newer hypervisor hosts. You can run a mixed version vSphere. Here's a summary of the information you're going to need to gather to set up your cloud provider configuration. It's based on an INI file, and the full details are in the doc linked with the link in this slide. You'll need this vSphere comp file whether you go with the kubeadm or a hardware route of passing command line flags to Kubernetes components. If you're on a distribution, this likely captures the same information, but you might not fill out this INI file directly. It might be involved with some sort of configuration capture through your distribution's installer. We're going to skip over the steps of OS install and configuration and container runtime install. They are in the documentation. I want to point out that you do have to disable swap in the OS. That's a Kubernetes requirement. And VMs hosting your Kubernetes cluster nodes have a few other considerations that we'll get to in the next few slides. The previous slide covered the in-tree cloud provider, but the out-of-tree cloud provider is going to need the same sort of information. If you do the hardware install, your command line option flags are just a little bit different, but the underlying information you need to gather in advance is the same. Here are some links to detailed docs for kubeadm-based Kubernetes installs. Now, kubeadm describes itself as a tool to bootstrap up a minimum viable Kubernetes, so you might need a little more. But my goal here is to document something, and this session isn't long enough to cover every install tool for vSphere that's out there. There's a lot of them, so I just picked kubeadm. A kubeadm install does conform to Kubernetes best practices and does support later upgrades. If you're on a commercial distribution, it likely comes with its own documentation and training materials, so refer to those. This slide describes the requirement for vSphere VMs that act as Kubernetes cluster nodes. I'm not going to read you all the details, but the advice is to set this up one time as a VM template and then clone that to as many VMs as you need to form cluster nodes. You could set this up with the vSphere GUI, but if you're a command line person in the Linux camp, GoVC is recommended. If you prefer Windows, PowerCLI can do these same settings. Most of you already know that vmwaretools is a guest VM to hypervisor host interface. You want to have it installed in your cluster nodes, but a warning, some CNI choices are going to need some non-default settings. If you're using Calico or Ontria, take a look at the link in this slide. Zone labeling is really useful when you want the Kubernetes scheduler to spread a multi-part service across potential failure zones. This topic could be a session all by itself, and indeed it was a session back at KubeCon China in 2018. Now, some of the material in that 2018 session is now a little dated, so I recommend that you refer to the documentation that's linked in this slide. You'll find detailed explanations with diagrams and examples there for setting up zones. Here's a logic flow that gives you an in-tree versus out-of-tree recommendation for the storage plugin. Myles is the storage expert, so at this point, I'm going to turn this over to him.
All right, awesome. Thanks for that, Steve. So like Steve said, I work at VMware. I'm a senior technical marketing architect, and my focus is storage. And in particular, over the last 2.5 years, my focus has been container storage, whether it's with Docker or Kubernetes or what have you. So what we're going to talk about here is the in-tree versus out-of-tree thing, but how we manifested that ourselves. So our in-tree driver was called the vSphere Cloud Provider. It was a minimum viable product. It actually came out of an internal hackathon project and was upstreamed into the K8s core repo. That is a good and a bad thing. We all know sort of the drawbacks of an in-tree driver at this stage. It pins you to a particular version of Kubernetes, all this kind of stuff. You know, you can't upgrade your storage integration if you don't upgrade the entire Kubernetes distro. There's security implications and a whole bunch of stuff. And it leads to bloat of the Kubernetes codebase, which is not a good thing. So the VCP was natively built into Kubernetes, part of the core code, like I said, and what it enabled was this policy-driven dynamic provisioning of Kubernetes persistent volumes. So that allowed you to specify things like data services at the granularity of an SPBM policy of a container volume. But I said before, you know, it had its drawbacks, so there is reasons why we moved on from this. So how did it actually work? And truth be told, it was quite simple. So there are two different ways that you could use this integration. Number one was you create a storage class and you point it at an existing SPBM policy in vCenter. So you can see that here. Whenever we create this storage class in Kubernetes, the storage policy name parameter actually points to the storage policy name in vCenter. So you've pre-created this SPBM policy in vCenter up front, and that gets mapped via the storage policy. Now, with the VCP, there was another option, and you could actually specify storage policy attributes directly in the storage class. So like you see here, this is an example for vSAN because it supports extra attributes like this, and we can specify host failures to tolerate of 1 and disk stripes of 2. However, what we realized was that as people use this and these policies weren't in vCenter, it led to SPBM sprawl. It made it hard to track volumes. So we have since decided to remove that functionality because, truth be told, most people just create the policy in vCenter and then use a storage class to point at it anyway. So that is what we had with the VCP. So what do we have now, and how have things changed? So CNS was introduced just as the out-of-tree movement was getting underway with Kubernetes, and going out of tree required us to develop a new storage plugin anyway. So we decided to just build from the ground up against the CSI standard because that at least allowed for code portability to other not other Kubernetes distributions, but other container orchestrators if we chose to do that in the future. And it takes advantage of this new CNS vSphere Storage API to provide some new features that we didn't have in the VCP. And CNS quite simply just stands for Cloud Native Storage. And it's a feature that's just built into vSphere these days. So if we look at this, look at the architecture, it's a little bit different to that of the VCP, you might note. So what we've got here is our Cloud Native Storage control plane that's built into vCenter, and we deploy a CSI pod into Kubernetes. The nice thing about that is, because it's just another workload running on Kubernetes, you can lifecycle your CSI pods and upgrade your CSI driver without having to rev your entire Kubernetes cluster. So if you're on Kubernetes 1.16 or whatever, you can upgrade your CSI. There's no need to upgrade the entire Kubernetes cluster just to get new storage features. So that's actually quite a nice lifecycle management benefit there. Like I said, it's built on the CSI standard for container storage, so it should be portable across other container orchestrators if we choose to entertain those in the future. That said, we really haven't had a lot of requests for other container orchestrators other than Kubernetes anyway, so it is what it is. As far as features, it enables the same sort of policy-driven dynamic provisioning that we got from the VCP. Same methodology for enabling it. Again, it's the storage class to SPBM policy mapping, so that one-to-one mapping of those two things. So operationally, very, very similar. But it does have some nice little bits and pieces that are tied into the vSphere UI that you don't get with the vSphere cloud provider. And this is just more reason why you might want to use this above and beyond what we had with the VCP, simply because it makes it much, much simpler for the platform administrator to help you troubleshoot what's going on at the platform layer, because we've got this traceability through the two layers, and we'll see that just in a second here. So if we look at how this is manifested in vCenter, we've got this new container storage view under the monitor tab, and you can see we've got all of our persistent volume names here, so all the PVC IDs are imported. Additionally, we have a metadata syncer that's deployed with the driver as well, so that will sync all of the volume labels that are applied to the PVs and PVCs into the vSphere UI as well. So if you need to filter by labels from Kubernetes, you can do that direct in the vSphere UI as well, which is really nice. And you can view some other bits and pieces. So what storage policy is being used, is it compliant, is it accessible, what size is it, and what container cluster is it being used on. So there's a whole bunch of really useful information here. So as for should I be using Intree or CSI, when it comes to distributions, you should probably use whatever your distribution distributor, your vendor, packages out of the box. So for most of those, that's the VCP anyway, but a lot of them are being validated and have been validated with the CSI driver and CNS. So I can name a couple here: Red Hat OpenShift, Docker Enterprise Edition, Rancher, Google Anthos GKE on-prem. They've all been validated with the CSI driver and CNS, but the long and short of it is, if you are running the CSI driver on a Kubernetes distribution that is vanilla Kubernetes bits, you will get support from vSphere from VMware as long as you have a valid vSphere license. Now, there are some caveats as to why you might still want to use, or maybe not want to use, but have to use the Intree storage provider. And that would be if you're on an old version of Kubernetes, so pre 1.14, which is whenever the CSI feature went GA. So if you're on an older version than that and you can't upgrade, then you're going to have to use the VCP. If you're on an older vSphere release than 6.7 U3 and you can't upgrade as well, because it requires the CNS APIs to be present in vCenter. Those were introduced in 6.7 U3. So if you have an earlier version of vSphere and you can't upgrade for whatever reason, then you'll have to use the vSphere cloud provider as well. However, if you can at all and those two cases don't apply to you, use the CSI. It's got more features, it's better supported. We support read-write once, read-write many volumes, and a whole host of other CSI features as well. So it would be our opinion that you should be moving towards looking at the CSI driver anyway. As for some resources on how you would learn how some of this stuff works, the CSI driver uses a different concept for creating disks called first-class disks, as opposed to just provisioning a VMDK with a VM attached. And two of the best blogs that you can find on that are by Cormac, so you can see those here. He's also got a very, very useful blog on CSI driver versions and their capabilities. I've since taken all that content and ported it into our GitHub as well. So if you look at our Git book, you'll get all that information there too. And then there's some other great information out there by Eric Shanks, Robbie Jerome, and Andrew Sullivan. So make sure to check out all of those bits and pieces on how to get it up and running. And not to pick a particular Kubernetes distribution or anything, but if you want a rough guide, because most distributions are exactly the same whenever it comes to deploying on vSphere anyway, there is a good blog out there for deploying OpenShift 4.4 on VMware vSphere 7, so go and check that one out as well. And sort of the next question that comes up is, so I've already got the VCP deployed, I've already got some applications running, and there's data in there, and I would like to use the CSI. How do I do that? So CSI Migration is being introduced as a gated feature in 1.19. The eventual idea is that all in-tree cloud providers will be deleted from the Kubernetes codebase. So we are providing a path that will allow users to upgrade their volumes from the VCP and import them into the CSI driver. And we do that by creating a lightweight sort of skeleton of the vSphere cloud provider, if you want to think about it that way. And we basically just proxy all of those commands into the CSI driver itself, and we do some upgrade procedures on the back end, like we change it from just a plain VMDK to a first class disk. So there's a whole bunch of stuff that happens in the background, but basically we're looking to move this to beta in 1.19, but it'll require an upgrade of your vSphere environment to the next version that's available, whatever that is. So this is something that we're working on. It will be there before the cloud provider gets removed from core Kubernetes, because that's a requirement anyway. But it will require an upgrade of vSphere to the next version, and it will require you to install Kubernetes 1.19 or above and the latest version of the CSI driver as well. So the current goal is to be stable in 1.20, but this is subject to change. It was 1.16, many moons ago. So this is something that keeps moving out a little bit, but it is getting more and more serious. There's a lot more development work being done on it now. So we are approaching something that looks like it's going to be final in the next couple of releases of Kubernetes.
So if you're using Kubernetes on vSphere, I encourage you to join the user group. We have a meeting each month where we present tutorials and best practices. The agenda is user-driven, so members are encouraged to nominate presentation and discussion topics, including feature requests. We have two user tech leads, Bryson Shepard and Joe Searcy, who couldn't be here today, but they helped us get this group started, and we're looking to grow this group with a diverse set of additional worldwide users. The group is also running a Slack channel, which is a great place to ask questions. The general Kubernetes user channel might be better for general Kubernetes questions, but if you have a vSphere specific topic to discuss, please go to the VMware users channel. It's a great place to find other users and to reach code and documentation contributors. So the next user group meeting is August 6th in the North America time zone. You can go to the Kubernetes community calendar to get a conversion to your local time zone and to add it to your calendar. Use the link in this slide to do that. You become a group member by joining the mailing list linked here. And finally, here's a link to the group's Slack channel. Myles and I are going to hang around for a Q&A. And here's a link that will get you this deck. Also, you'll see here our GitHub IDs. Thank you, and I hope to see you in a future meeting.
感谢 Stephen Wong 和 Myles 的分享。我们下面进入 Q&A 环节。Thank you for your great talk, Stephen and Myles. Now we are moving to the Q&A session. For the audience, if you have any questions, please raise them in the Q&A column, and Stephen and Myles are here for you to answer your questions.
I see there are already 2 questions queued up in the chat. So I think I'll take a shot at answering them. And Myles, why don't you step in too? Because I think the 2 of us put together probably can put together a better answer. So the first question I see is, as an end user of VMware, any recommendation for us to leverage Kubernetes or going cloud native? I also see that Alice Jin would like to answer this question live. So Alice, if you're online, why don't you go ahead and answer if you like.
Oh, hi, Stephen. Alice Jing is just there to be monitoring.
Oh, okay.
So you
sorry, I misunderstood.
To answer the question by yourself. Thank you.
All right. So for leveraging Kubernetes, the first step, of course, is to learn Kubernetes, learn what it can do and what it can't do. You know, it's become really popular, but it isn't a tool that does 100% of things. But there are very many use cases for which it is a great tool. And I think the best way to learn it is to start in and use it, because unlike the situation of 5 years ago, it's no longer difficult to install and get going. If you're already an end user of VMware, presumably you have infrastructure to stand it up on. But there are smaller versions that are appropriate for learning only, even if not for production, that could be run even on a personal laptop. There are a lot of training materials out there on the generic Kubernetes. And I would start with the generic Kubernetes because the fact is, by design, Kubernetes is not a whole lot different on vSphere than it is when running on a public cloud or other platform. The whole purpose of Kubernetes and what cloud native means is that you can run an app anywhere. And if things work properly, that app really shouldn't be able to tell where it's running and should be quite portable across all the platforms. It's only when you get to that later stage that is approaching operations where things start to become a little more platform specific, where you're dealing with things like deploying Kubernetes in a way that's very resilient and has high availability. Then it pays to get into the details of best practices for running on your platform. There, you can go to sessions like this, and there are other ones that got pre-recorded in Kubernetes in KubeCon events going back a couple of years. And the sessions were labeled vSphere Cloud Provider rather than User Group, because this user group didn't exist back then. And then, of course, join our user group meetings. They occur once a month. We're bringing in speakers to give presentations, ask user questions, and generally talks on best practices plus roadmap items. Myles, would you like to add anything?
Yeah. So I think the way that these questions are sort of phrased, because they're both by the same person here. I've noticed the next one is, what is the best path to take my IT team to make my IT team ready for VMware and K8s? It sort of alludes to the fact that K8s is an inevitability, and maybe that's the case and maybe that's not the case. It depends on your application. Like Steve said, it doesn't do 100% of things, but it does a lot of things quite well, and it is very well suited to the things that it is suited for. When it comes to using Kubernetes or going cloud native to me is the application takes over all of the resiliency and underlying infrastructure tasks from the infrastructure itself, and sort of abstracts that away. So where typically you might have a Microsoft SQL Server that is replicated or something like that, you would use a database like Cassandra, or something like a key value store or Kafka that does the data replication at a higher level, rather than relying on the underlying infrastructure to do replication. So cloud native is more about making the application more resilient in itself and making it less dependent on the platform. And like Steve said, Kubernetes provides that abstraction layer that sort of makes the underlying platform almost generic to most of those applications. The experience, on vSphere or on a public cloud or whatever, should be largely the same. given that the Kubernetes APIs are identical everywhere. But obviously, you know, once you move into production and you start to operationalize that, there are some slight differences from cloud to cloud and from vSphere to other clouds and things like that. But on the whole, your application should be portable from cloud to cloud. Now, when it comes to making your IT teams ready for Kubernetes and cloud native, I would say the first thing that you should do is look at your current applications, and are you interested in taking those current applications and porting them to a new platform? So you're going to move them from VMs into containers, and once you've moved them into containers, are you going to rewrite parts of those applications to use maybe different databases or whatever that can run on top of Kubernetes and in a more sort of generic fashion? So to me, really the first step is engaging with the developers that you have in-house or such. Or even if you don't develop software in-house, you know, having a K8s platform that you can easily deploy and use is very important, because there are applications that we're seeing that are being deployed now that will only run on Kubernetes. So especially if you don't write applications in-house, having some kind of distribution that does all the hard Kubernetes lifecycle management stuff for you and configuration for your platform would be really advantageous. So engage with your developers, figure out what they're doing, how they're using containers, and maybe how they could look at including Kubernetes and continuous integration into their workflows, and how that might influence how you're going to deploy applications in the future. And then take a look at your infrastructure. You know, what versions of vSphere are you running? Does it need to be updated to run these new versions of Kubernetes to get the features that you need and that kind of thing? But there are tons of resources out there for generic Kubernetes. There's the Kubernetes.academy, I think it's called, Steve. Is that correct?
Yes, it is. It's Cube Academy.
Cube Academy,
And
yeah.
another thing I want to point out is it's not an all or nothing. So a good way to get started is to just cherry pick the easy things to move over. And it's entirely possible to keep a hybrid operation going where the bulk of your legacy doesn't move, and it's really the new applications that you're moving over to Kubernetes. And to the extent you can, the easy low-lying fruit is to go after stateless applications first. Maybe instead of moving your databases to the new cluster-aware model that Myles alluded to, you could actually keep your state like traditional transactional SQL databases over on in VMs at the beginning, but move the apps that consume them over to Kubernetes and have a hybrid. And there are tools that might even be available. They really technically are not Kubernetes. They're in the collateral cloud native landscape tool chain. Things I'm talking about, things like service meshes that are capable, at least in some of the versions of the meshes, of integrating legacy VMs with new Kubernetes applications and services. So don't plan on this being a big switch of everything moves overnight. It doesn't have to be that way, and it shouldn't for most people.
Yeah, I think it's an evolutionary thing. You start with the easy stuff, like Steve said, move over the stateless bits and pieces. Those are the easy things to do. So stuff like your web servers, you know, Nginx, Apache, app servers like Tomcat, those are prime candidates. They're very, very easy to move over, and they can still talk to external VMs. You know, everything doesn't have to run in Kubernetes. So if you do have existing big databases like Oracle or MS SQL or, you know, whatever, you can still use those and you can still have your applications talk back to them. And maybe like a good sort of proof of concept is if you're building new functionality into your existing applications, just build that new functionality as like a stateless dumb front end, deploy that into Kubernetes and have it talk to your existing backend that runs inside VMs, and use that as like the first step so that you get your feet wet, you understand how the operational models work, you understand how to deploy things, and then maybe look at refactoring some of your other bits and pieces into Kubernetes over time. But I would imagine for most enterprises that are running these kinds of things, it'll be a multi-year transitionary project to really move everything into Kubernetes. Like Steve said, it's not overnight. This is a transformational thing that will take some time.
And there are a lot of training materials. There are even certifications to get your staff trained, but there are also collateral tools that help your staff kind of avoid becoming experts from top to bottom in Kubernetes. I'm talking about things where they can continue to use the existing languages and tools they're familiar with and have some kind of external build tool assist them in packaging those things into Docker containers. I think for troubleshooting and debug, they still have to learn what's going on from a high level view, but you don't have the scenario where you have to train 100% of the existing development staff on the new tools from top to bottom at a microscopic level. So go out there and it's fair to say that in many categories, you can pick your language and you won't be the first one to do that move over to Kubernetes. And you'll find that there are tools available to assist you in doing that in a CI/CD environment. So I think that those are the only questions in chat. If anybody has any additional questions, now's the time. Go type them in the Zoom chat, or I don't know if there are other forums that people are online on to submit questions.
I would also say if you haven't got a question right now, go to the Kubernetes Slack and join the User Group VMware channel, and you can always ask questions there. And Steve, myself, and a bunch of other VMware engineers and people will be in there to answer your questions too.
Yeah, thank you for the questions, and thank you for the great talk and answers from Stephen and Myles.